Good morning, ladies and gentlemen. May I have your attention, please? Thank you. Let's go ahead and get started. Just because last class period, right, with our assembly schedule, we didn't get to do the softball pop-up problem as we worked to develop the derivative as a function in its own right. And I want to make sure we have a chance to work with the graphing calculator. So if you don't have one today, make sure you check one out from the front calculator tab. We'll be using that later, along with the stat list edit feature. And we'll also go ahead and make sure that we know how to do a draw tangent line command on our graphing calculator. And so there's some neat tools we're going to be looking at using technology today. I've also modified last assignment, and so we didn't do the softball pop-up problem, and the algebra challenge question was kind of a spin-off of that, an extension of that. And so what I've done is I've taken off those two questions from the algebra challenge question of OTL number 4, and so you won't have to turn an algebra challenge. After we do the softball pop-up today, we'll add that algebra challenge then to today's OTL number 5, and you'll turn it in next time. So it'll still be an assignment. It's just not going to be included in today's turn. So hang on to your algebra challenge question. That won't be turned in today. That was meant to be completed after the softball pop-up problem. So thanks for bringing that to my attention. Let's go ahead and get started on our Bellwork now. Raise your hand at this time if you do not have a red mark. So not have a red mark. All right, so we need to be able to find the equation of a tangent line to a curve at a particular point of concern algebraically, right? So we have tools involving technology, and we'll be able to check and verify this several different ways, but we still need to be able to do it algebraically in case this appears on a non-calculator portion of an exam. So let's go ahead and generate the equation of the tangent line algebraically, and we'll do that using the definition of the derivative. So we know that with letters, with x's and c's and f's, my definition for the first derivative of a function f at a point is given by f prime. Well, this isn't going to work very well. Sorry about that. The derivative of a function f at an x value, x equals c, is given by f prime of c equals the limit as x approaches c of my average rate of change quotient, my difference quotient, f of x minus f of c all over x minus c. What makes this give me the derivative, the instantaneous rate of change, is the limit expression. So if you don't have the limit here, then it's just an average rate of change calculation. The limit expression is what's going to allow us to get rid of the problem, that problem factor that shows up on the bottom. If you let x approach c, that interval between the 2 points in your slope calculation is shrinking to 0, right? It's going to give us the instantaneous rate of change. We need to be evaluating a limit so that we can get rid of that problem factor. All right, let's go ahead and apply it in context here. We want f prime of 5. That's given by the limit as x approaches 5 of f of x, which is the square root of x minus 1, minus f of 5 would be go to the function rule, plug in 5 and see what you get for the y coordinate. I get square root of 5 minus 1 is square root of 4, which is 2, all over x minus 5. So there's a particular function in x value concern plugged in my definition of the derivative. Raise your hand if you got this far. So you're able to generate the definition. Great. Now let's go ahead and evaluate that. If I were to plug in 5, I get a 0 on the bottom. That's undefined. No problem. We'll go ahead and multiply top and bottom by the conjugate of the numerator. That will allow us to get rid of the radical term, and we'll see if we can simplify from there. So the conjugate is the same terms, root x minus 1 and 2. It's just opposite operation. So we should multiply top and bottom by square root of x minus 1 plus 2. That's the conjugate of the numerator. On the bottom, same thing. On top, I will FOIL that out, but on bottom, I'll go ahead and leave it fully factored, right? We don't need to try to distribute or multiply or FOIL on the bottom because we'll create additional radical terms, right? And we want to be getting rid of that x minus 5. We want to leave it as is in the hopes that this will simplify. So let's go ahead and see what happens. On top, we're going to do first, outer, inner, last, and we'll get root x minus 1 times root x minus 1 is x minus 1. My outer and my inner are going to be exact opposites and sum to 0. Do I need to write them out, or can we just sum to 0 and go to the last? The last is going to be minus 2 times plus 2 is minus 4. And we can see the fruits of our labor, right? Already we know that's going to become our x minus 5, the column factor. It was giving me a 0 on the bottom. So we're in good shape. We'll leave this as x minus 5. We'll leave this as root x minus 1 closed radical plus 2 closed quantity. And now we'll go ahead and see this x minus 1 minus 4. That is just equal to x minus 5. Hooray! Because that's what we wanted to be able to cancel out on bottom. What enables us to cancel it out is the fact that we're evaluating a limit. And x does not equal 5 as we evaluate the limit as x approaches 5. Therefore, we can cancel out those factors and try to evaluate the limit as x approaches 5 of 1 over root x minus 1 closed radical plus 2. For the first time, right, my x value of concern, x equals 5, is in the domain of my expression, so I can evaluate through direct substitution and drop the limit. I'm going to get 1 over root 5 minus 1 is root 4 is 2 plus 2. I'm getting 1/4. Raise your hand if you already had 1/4. 1/4? Yes! Good job. So we've got an algebraic calculation of the value of the derivative. What does this 1/4 represent in the context of the problem? What's that 1/4 mean and have to do with the function? Allie? Absolutely. So this is the slope. This is the slope of the tangent line. So let's see if we can generate that right up here. We'll go ahead and import that. So we're going to use my slope of the tangent line is given by 1/4. And now we can start out with our age-old point slope formula, right? Y minus y sub 1 is equal to m times quantity x minus x sub 1. Where x sub 1 comma y sub 1 is simply my point of tangency, and m is the slope of the tangent line. So here we go. Y minus, what was my y coordinate? Well, my y coordinate we already got was f of 5, and that was negative. Nope, that was 2. That was 2. And so we'll go ahead and put 2 here, equals 1/4 times quantity x minus, and this was 5 for my x value concern. So if I were to rearrange this and solve for y so that I can enter in my graphing calculator, I would get y equals 1/4 x minus 5/4, and then I'm going to add over that 2, so that would be plus 8/4. So I think my final answer is going to look like y equals 1/4 x plus 3/4. Raise your hand if you already generated that. Did you get 3/4 for your y-intercept? Great. Now you don't have to go all the way to here. You could have left it here if there's no, it doesn't specify, or simply added the over the 2, right, to this expression. Now you can still enter in your graphing calculator. In any case, we want to verify. So what I've done is I've taken screenshots of y equals root x minus 1 and y equals 1/4 x plus 3/4, and I've graphed them on the same window, and so it looks like that does touch the curve at the point when x equals 5. Then I went ahead and numerically did the tangent line. So this is a new thing. Everybody, let's go ahead and do this with our graphing calculator. Now we did this in 1B, but because of the assembly, we didn't have a chance to do it here. So everybody, let's go ahead and enter our y equals menu, the original function, square root of x minus 1. So let's do second square root of x minus 1. Close radical. It looks like this is on -1 to 7, maybe. And -1 to 5. That looks pretty good. Okay, so let's go ahead and draw a tangent line using our graphing calculator commands. So everybody, here we go. We're going to go second program is the draw menu. Everybody find it. Second program is the draw menu, and we want to select the 5th option for tangent line. So we'll go second program, that's the draw. We want the 5th option for tangent line. After selecting that, we're going to go ahead and enter our x value concern. I want to do that at x equals what? 5, so we'll do 5, enter, and watch this. The calculator will draw a tangent to the curve at my specified x value. We said x equals 5. Then it will spit out an approximation for its equation. How cool is that? Well, we didn't get 0.250000002x plus 0.749999999, or did we? Right? Your calculator, we did it better. Your calculator is giving it the old college try. It's really trying to tell us that the equation of the tangent line is 1/4 x plus, right, 3/4. And so we did it exactly, and it's giving us an approximation. Keep that in mind, right, as you use technology. Remember, your calculator is only using how it's programmed to come up with things numerically, and it'll have decimals. You have to infer that that is 1/4 exactly, and 3/4 respectively. Does that make sense? Awesome. Depending upon your window, you might get it exact. Yesterday we got it exact in 1B with a different equation, so that's pretty cool. Awesome. What questions then? Wait, I kind of want this on this one. And so it tells us the equation of the tangent line. That's pretty neat. Yep, it tells us the equation of the tangent line, so that's pretty neat. Awesome. What questions do you guys have about the command? So where was that? Second program. Second program is the draw menu, and we wanted tangent and then enter x value concern, enter. That's pretty sweet. Okay, so we've got some housekeeping to do. This is for our 2A class only. We did not collect OTL number 3 last time in the interest of time. So at this time, we need to collect OTL number 3. This is from 2 class periods ago. Go ahead and take out your OTL number 3. Make sure that your name, first class, is on top. If you need to staple it, please do so. Both staplers are over on the side activity table. If you have multiple pages, please staple those together. Give yourself credit for those you complete out of 13. Divide, enter, multiply by 2. Inbox your infinite canvas score. Balance the nearest half point.
For number 4, you want the sheet?
Nope. Oh, for number 4?
Yeah. The one where we were drawing.
Yes, I think so, but
okay.
Yes, I think so, but hang on, just do number 3 right now.
Does anybody need the stapler?
Jake, I think no, I don't want it. I think no, I don't want it because I just have out of 17. Otherwise, it would be. I just wanted you to do it for practice. Okay, so we're OTL 3. We're passed up. Thank you, guys. Thank you.
Or did it include a sheet at all?
No.
Yeah, it is.
Okay, ladies and gentlemen. Next up, OTL number 4. Ladies and gentlemen, I've decided to take off the algebra challenge question because it's kind of an extension of the softball pop-up problem, which we didn't have time to do in class. So please do not staple your algebra challenge question to it. While 1B's will be out of 19, yours will just be out of 17. Okay, this does not include the y to y prime. That was for practice. Does not include the y to y prime. This is just book problems and no algebra challenge. So I think this can all be notebook paper. Give yourself credit for those who do that at 17, please. Divide, enter, multiply by 2, and we'll get you credit for OTL number 4. Then next class, your OTL number 5 will include the algebra challenge question. So there'll be an additional 2 added on. So once again, algebra challenge question will be due next class. Does that make sense? Very good. We just shuffled a little bit because of our assembly. Table down on the side. Sorry. Are we good with number 4? Number 4? Okay. You guys are great. And so what I'm going to do, because I have the good recording for the softball problem, last class at 1B, I'm going to go ahead and pause the recording now, and we'll investigate the softball problem. So please go ahead and find. Now we need to hurry a little bit here as well. Okay, so next week we'll be having our first discussion forum on our Moodle webpage. And so the discussion forum is an opportunity for everyone in class to interact with our course concepts in a different way, not just sitting at our desk with pencil and paper or working together during class with our activities. And so next week we're going to have Celebrity Showdown 2015, where you are going to, right, you're going to get a prompt from me every Monday morning now from the remainder of this school year, except sometimes on test week we don't do it. But every time we have a new concept introduced during the course of a week, you're going to get a prompt posted on Moodle Monday morning. And in that prompt, I'll give you directions as to how you need to put your original post on our Moodle website discussion forum by Thursday, 11:59 p.m. Moodle time. After responding to my original prompt and completing your original post, you're going to read the posts of your classmates, and you're going to choose a classmate to respond to, right, based on directions in my prompt. And so you'll respond to a classmate then by Sunday, 11:59 p.m. Moodle time, and it's an easy way to earn points outside of class. So say you didn't do as well as you had hoped on the Unit 2 test, an easy way to earn points and help mitigate that, right, is to complete your Moodle discussion forum posts outside of class in addition to your regular OTLs that you're doing. So this first time around next week, it's only going to be the original post to test the settings and make sure that everybody is able to post on the Moodle website discussion forum. And then thereafter, it's going to be a two-phase post every single week. The original post responding to my prompt by Thursday, and then responding to a classmate, right? Responding to a classmate by Sunday of that week, 11:59 Moodle time. And that's the way to earn 3 points plus 2 points is a total of 5 points every week in the discussion forum. It's a great opportunity to interact with our calculus concepts in a different way. It might be find a calculus concept outside in the real world that we're talking about in class. It might be create your original function that models a particular phenomenon, and so it's a great, fun thing to do. Last year we had lots of fun. We've got some, you're welcome to use clip art or GIFs, little video clips, memes, whatever, to help accentuate your post if you feel the need, and so there's some fun stuff with that. I look forward to that, but first let's go ahead and do our derivative at a point. So right now I'm going to distribute a little jigsaw activity. What I'm going to do is I'm going to give you a random letter A, B, C, or D, and you're going to work to complete that. Then we're going to go ahead and come back together and we're going to share our findings. You Okay, as soon as you do it, go ahead and get working. We're going to go ahead and generate using the definition of derivative. Both the derivative of that constant function and the derivative then of that linear function. Okay, ladies and gentlemen, let's go ahead and come together and share our findings thus far. In the interest of time, we're not going to mix and mingle and find an A, B, C, and D to mix and match with. We're going to make sure that you have some time to work on your 3-4 activity. So what we do is generalize our findings thus far from those who have completed. So we've got our colored paper. We had 2 categories. Everybody had 2 categories. They had a constant function, that is f of x equals some constant k. We know graphically that appears as a horizontal line in the xy coordinate plane. And we had a second function in number 2, call it g of x, and there were different functions, right? But in each case, they were given by some linear equation, call it mx plus b or a plus bx. We'll do mx plus b in the interest of consistency. What did you get for your derivative f prime of x if your original was a constant k? So f prime of x, what did you get for your value of the derivative for that? Kobe?
0.
0. Raise your hand if you got 0 for your constant function's derivative. That's correct. The instantaneous rate of change in that constant function is 0. Using the limit definition, you get a 0 on top that's divided by a quantity approaching 0. Because on top is straight up 0, not a quantity approaching 0, it's not an indeterminate form, right? It's 0 divided by an algebraic expression. That's always going to be 0, and that's how we can get to 0. G of x for a linear function, right? G of x equals mx plus b resulted in g prime of x relating to this original function. Now, when you had, Anna, what did you have for your linear function?
Negative 1 plus 5x.
Negative 1 plus 5x, and what did your g prime of x give you? 5, right? And someone had 1 minus 2x, right? 1 minus 2x, what did you get for the derivative of the function g of x equals 1 minus 2x? Paige, what did you get for that? For your second function, your linear function?
Oh, negative 2.
Negative 2, right? In each case, the derivative value is which part of your original function?
Slope.
The slope. And so if g of x is given by mx plus b, then g prime of x equals m. And that'll be part of your assignment tonight. But now, in the interest of time, we're scooching everything around because of your assembly. We've cut out a stamp 9 on the proof, and we're down to 4 stamps for your activity 3-4, another definition of the derivative, an easier way to find the derivative. Everybody circular stamped algebra items 2, 3, 8, and 11. 2, 3, 8, and 11. I'm going to pause the recording. We're going to come back together at about 25 for our closure. About 25 after for our closure. Okay, ladies and gentlemen, let's go ahead and take a look at our closure and summarize our findings for the day. And so for our closure activity, we're going to go ahead and get the 3 rules that we learned, today, and then apply them for numbers 4, 5, and 6 to several different power and linear and constant functions. Please be ready to share your response with the whole class and their comments. Okay, ladies and gentlemen, at this time I ask you to go ahead and take a look at the smartboard, and I'm going to call on you to share your response. And so we know our general rule for the derivative of a power function with x's and n's. If my original f is given by x to the n, then the derivative f prime of x is what with letters x and n? Meg?
N times x to the n is 1.
Absolutely. There's our power rule that we can now apply, right, forever as a result of that bear of a proof on the extra handout. And so n times x to the n minus 1. That is exponent times that base raised to 1 less than the original. If f is given by a constant times a function, that is k times g of x, then f prime of x is given by what? Nikki? Absolutely, thank you. If f is given by a sum of functions, u of x plus v of x, then f prime of x is given by what? And what did you get for that? Jake?
U prime of x plus v prime of x.
Excellent. That is, the derivative of a sum is simply the sum of the individual derivatives. That is, you can differentiate through a sum or difference. Right? You can go term by term. Excellent work. Now let's go ahead and apply our rule in turn. So I'll go ahead and differentiate the sum or difference term at a time. It looks like power rule minus another power rule. So in the interest of time, we'll go right to our answer. Ready? 7x to the 6th minus 4x cubed. The derivative with respect to x of negative 4x plus 11 is going to be the derivative of negative 4x is negative 4. And the derivative of a constant is 0. And lastly, the derivative term by term would be 15x squared minus 26x plus, what's the derivative of pi? 0. The pi is just a constant, the derivative of any constant is 0. Excellent work today, ladies and gentlemen. If you still need your 8 stamp, you can get it next time. If you still need your 11 stamp, you can get it next time. We're glossing over the justifications on the lines, right? But I still expect you to look at and read through the proofs, okay? Have a great day, ladies and gentlemen. And I apologize for the crunch, but it was because of the assembly on Tuesday that we're all catching up from.
Yeah,